Good morning. Today we will be starting our second unit, Combustion in SI engine. In this unit, we will be covering topics like flame development and propagation, stages of combustion, ignition lag, effect of factors on flame propagation that are air density, temperature, engine speed, turbulence, ignition timings, physical and chemical aspects, abnormal combustion, effect of engine and fuel variables on abnormal combustion, causes and remedies, and some salient features of different types of combustion chambers that are used for SI engine. So, starting with our first topic, the first topic is combustion process in a SI engine. The combustion may be defined as a chemical reaction in which certain elements of fuel like hydrogen and carbon combine with oxygen, liberating heat energy and causing an increase in temperature of gases. The conditions which are necessary for the combustion to take place are the presence of a combustible mixture, some means of initiating the mixture like a spark plug or a fuel injector in case of CI engine, stabilization and propagation of flame in the combustion chamber. The theory of combustion is a very complex subject and has been a topic of research for many years. In spite of this, not much knowledge is available concerning the phenomena of combustion. The process of combustion in case of SI engine take place in a homogeneous mixture. In SI engine, a nearly homogeneous mixture of air and fuel is formed in carburetor. Homogeneous mixture thus formed outside the engine cylinder, and the combustion is initiated inside the cylinder at a particular instant towards the end of compression stroke. The flame front spread over a combustible mixture with a certain velocity. In a homogeneous gas mixture, the fuel and oxygen molecules are more or less uniformly distributed. Once the fuel vapor air mixture is ignited, the flame front appears and rapidly spread through the mixture. The flame front is a narrow zone separating the fresh mixture from the combustion products. Under normal operating conditions, we can divide the combustion in SI engine in two general types. One is normal and another one is abnormal combustion. Under normal operating conditions, the combustion is initiated towards the end of compression stroke at the spark plug by an electric discharge. A turbulent flame develops following the ignition and propagate through the pre-mixed charge of fuel and air, and also the residual gas in the clearance volume until it reaches the combustion chamber walls. In normal combustion, the spark ignites and a smooth burn travels through the combustion chamber. The flame initiated by the spark travels across the chamber in a uniform manner. But under certain operating conditions, the combustion may deviate from the normal course, leading to the loss of performance and possible damage to the engine. This type of combustion is known as abnormal combustion or knocking combustion. The consequences of this type of combustion are loss of power, recurrent pre-ignition, and mechanical damage to engine. As we can see here, there is a mechanical damage to our engine piston. Such type of damages occur in case of abnormal or knocking combustion. So to avoid these abnormal combustion, a high auto ignition temperature and a long ignition lag are the desirable qualities for SI engine fuel. which we will be seeing in detail in further lectures. Now, coming on to our next topic, the first main topic is stages of combustion in case of SI engine. Here we can see a theoretical pressure crank angle diagram during the process of operation in an SI engine. In this, we can see compression from point A to point B. Then we have combustion from point B to C. That is, theoretically, we know that heat is added at a constant volume. And the combustion is instantaneous. So the pressure is increasing within at an instant. Then from C to D, it is our expansion stage. This diagram is for ideal SI engine, but in actual engine, this does not happen. The detailed process of an SI engine of an actual cycle can be seen here. In an actual engine, the combustion process in an SI engine consists of three stages. The first one being ignition lag, second is propagation of flame, and third is after burning. The pressure variation during the combustion in a practical engine is shown in this diagram. In this figure, A is the point of passage of spark. B is the point at which the beginning of pressure rise can be detected. C is the point of attainment of peak pressure. Thus, AB represents our first stage, BC is representing our second stage, and CD is our third stage. The first stage is our ignition lag, or you can call it as a preparation phase, in which the growth and development of a self-propagating nucleus of flame take place. It is basically a chemical process depending upon both temperature and pressure and the nature of fuel, and also the proportion of exhaust residual gases present in our engine cylinder. The time taken for this stage is usually 0.00015 to 0.00002 second. 0.0002 second. This is the time which is usually taken by this preparation phase. The second stage, BC, is a physical one, and it is concerned with the spread of flame throughout the combustion chamber. The starting point of this stage is the point at which a first measurable rise of pressure is seen on indicator diagram. Or you can say the point where the line of combustion is departing from the compression line. This can be seen from the deviation of the motoring curve. During the second stage, the flame propagates practically at a constant velocity. Heat transfer to the IC engine cylinder wall is low because only a small part of mixture comes in contact with the cylinder wall during this period. The rate of pressure rise is directly proportional to the rate of heat release during this stage, since the combustion chamber volume remains practically constant. The starting point of third stage, that is afterburning stage, is usually taken at the instant at which the maximum pressure is reached on the indicator diagram, that is point C. The flame velocity decreases during this stage. The rate of combustion becomes low due to lower flame velocity and reduced flame front surface. Since the expansion has already been started before this stage of combustion, with the piston moving away from the top dead center, there can be no pressure rise during this stage and the pressure goes on decreasing. So these are the three stages of combustion in case of SI engine. First is our ignition lag or preparation phase, or you can call it as time interval in the process of chemical reaction gets heated up to self-ignition temperature. It is very small and lies between 0.00015 to 0.002 second. Second one is our flame propagation stage. Flame propagation, once the flame is formed, it propagates through the mixture, and rate of heat generation is generally greater in this stage as compared to that of rate of heat loss. Pressure rise is also slow during starting, since the mass of mixture which is burned is small. Therefore, some ignition advance have to be given of about 30 to 35 degrees so that the peak pressure can be obtained at 5 to 10 degrees of the top dead center. After burning, after the attainment of peak pressure, combustion does not stop completely. Some amount of combustion remains there. Flame velocity decreases during this stage, and rate of combustion becomes low. And practically, there is no pressure rise during this stage since expansion have already been started. So these were the stages of combustion in case of SI engine. Next, in the next class, we will be seeing the flame front propagation and the factors which influence the flame speed in case of SI engine. Thank you.